excited to introduce Giovanni Acampora, full professor of computer science at the University of Naples. And we're going to talk about quantum artificial intelligence. And I will leave directly the word to him to introduce himself and the talk. Thank you very much.
Thank you. Okay, thank you for your kind introduction. First of all, I would like to thank the organizer for inviting me to this important event here in Naples. And today, it's my pleasure to introduce you with some research results about quantum artificial intelligence. So I would like to introduce you with these topics, in particular with the concept of artificial intelligence, the concept of quantum computing, and I would like to show how these two technologies can be merged together in order to create this innovative research field named quantum AI, quantum artificial intelligence. So, what is artificial intelligence? So today, everyone discusses about AI. We use AI every day with ChatGPT and with other mobile apps and so on. But from the computer science point of view, what is AI? AI is the capability of computers to emulate the abilities of biological entities, such as, for instance, human beings. Okay? In understanding, learning, making decisions, and adapting to their surrounding, okay? To the environment they live. And in particular, in order to understand this definition, we can make some examples. For instance, an example is related to autonomous driving. Okay? An autonomous car uses computers and AI to see the road, learn from experience, make decisions like when to stop or start, and adjust to what's happening around it, just like a human driver would. So this is an example of AI tool, the autonomous car. At the same time, similarly, we can introduce the concept of robot vacuum. Okay? A robot vacuum is an AI tool because it is able to detect obstacles, learn the layout of your home, to define the map of the environment, decide where to clean next and adapt to the change in its environment, just like a person would when tidying up a room. Okay? So they are emulating people in performing some activities. And now, maybe everyone knows ChatGPT. ChatGPT is another example of artificial intelligence tool based on large language models that is able to understand the language, learn from patterns in text, decide how to respond, and adapt to its answer based on the conversation. Okay? So this example are implementation of the definition I shown in the first slide. Okay? So now we know the definition, we know the application, but how is it possible to implement this application on our computers, on our mobile, and so on? This is possible thanks to the concept of machine learning. Okay? Artificial intelligence can be viewed as a kind of group of different methodologies. We have reasoning methodologies, problem-solving methodology, optimization methodologies, but currently the most used and the most important part of artificial intelligence is named machine learning. That is a methodology of artificial intelligence that allow computers to learn from example and improving their performance step by step without needing instruction for every task. Okay? So thanks to machine learning, a computer is able to learn from experience, and this experience is represented by past data. Okay? And currently, the most used approach of machine learning are neural networks. Okay? And the neural networks are the main tool behind today's smart computer, behind ChatGPT, behind every kind of AI system. There are neural networks. Okay? And what is the goal of a neural network? The goal of a neural network is to emulate the behavior of human brain. Okay? Human brain is a collection of cells named neurons interconnected by synapses in a very simple and abstract way. And so during our experience, during the human being's experience, we are able to train our neurons to learn how to perform some activities. Okay? And so it's thanks to the experience that human beings are able to train their brain. And at the same way, a computer can learn from experience thanks to the idea of neural network. Okay? This is a very simple neural network, emulates the concept of brain. The circles are the neurons, and the arrows are the synapses among the different neurons. And moving from the input to the output through the hidden layers, we are able to perform some calculation. Okay? A neural network that is a way to simulate the brain is just a mathematical computation. Okay? As a mathematical computation that allow us to perform complex activity, such as, for instance, recognize an image, such as, in this case, we have a cat. We would like to recognize this cat. We use the different pixel of the image as input of this neural network. We move from left to right by means of mathematical computation, and at the end, in the output layer, we get the probability that the image is related to a bird, cat, or dog. And as you can see, here we have the 99% to be a cat. Okay, but it's just a mathematical computation. And what is one of the main ingredients of a neural network that allow a neural network to behave in a correct way? It is the concept of weight. This W variable in each layer, these are the weight of a neural network and the behavior of a neural network depending upon the value of the weight. So it is very important to train a neural network to set up the value of the weights in a proper way in order to allow the network to have the right behavior. And this is the most important part of an AI tool. Okay? When we discuss about AI, the complexity of AI from the computational point of view is related to the training of the AI. Okay? So when we train a network, the result of the training, the value of the weights, can be organized in a matrix, okay? In a collection of numbers. So the neural network, from a graphical point of view, from a graphical point of view, can be considered as a graph, okay? A collection of nodes interconnected by arrows. But from the mathematical point of view, a neural network can be represented by using the weight matrix, okay? That is the matrix that we need to learn in order to allow the neural network to work properly. Now, what is the problem? That current AI systems are very useful, are very good, but they are very complex. What means they are very complex? That the number of weights that compose this AI network is very, very high. Okay? In particular, if we consider system like ChatGPT, the number of weights that ChatGPT use to work properly is between 500 billion and 1 trillion. So we need to train this very huge matrix in order to allow ChatGPT to work properly, as you know. Now, I show you how a matrix related to a neural network is represented, okay? But how this matrix is stored in a memory of a computer. This matrix is stored as a sequence of bits, okay? You know that in the memory of a computer, we have a collection of binary digits, 0 and 1, okay? And because each number, each weight of a neural network can be represented by using, for instance, 32 bits, I need a very huge number of bits to store an artificial intelligence model, okay? Because I have a very huge number of weights. To represent each weight, I need several bits. So in the memory of a computer, I need several bits to store a neural network. And so this is the problem that we would like to face. We need a way to train artificial intelligence system composed of billions on trillions of weights, where each training step involves performing several operations on this number, we can use specialized hardware such as GPU and TPU to speed up this process. But however, there is a big problem. The big problem is that current computers cannot be further improved. Current computers are strongly related to the Gordon Moore. And because the size of a transistor is becoming very, very small, is it no more possible to further improve the performance of computers? And so how we can deal with the next generation of AI system if current computers cannot be improved in the future? The solution is in quantum computing. Quantum computing is a very complex topic, and in order to explain you what is quantum computing, we will deal this topic by using maybe the most used example, that is the Schrödinger cat. Okay? And for this reason, this slide says a cat can save us, because thanks to these phenomena related to the Schrödinger cat, we will be able to build computer more powerful than the classical computer we use today. Okay, what is quantum mechanics? Quantum computing is different from classical computing because it is based on a different physics. Current classical computers are based on classical physics. Quantum computing is based on quantum mechanics. And quantum mechanics is that part of physics that describe how behave teeny particles, such as electron, proton, and so on. And why quantum mechanics is different from classical physics? Because this particle can have some behavior very strange. Okay? For instance, this particle can be in different position at the same time. Okay? And this is not possible in the classical world where we live. I am here and I cannot be simultaneously in another place. But when we deal with quantum mechanics and with very teeny particles, so it's possible to have this phenomena related, named superposition, that allow these particles to live simultaneously in different positions. Okay? And starting from this discussion, we can introduce the concept of Schrödinger cat. Okay? If we move this quantum mechanical vision to the classical world, we can say that if we put a cat in a box in a particular experimental configuration, so this cat can be simultaneously dead or alive, okay, at the same time. Obviously, the experiment is not so simple. It depends upon some configuration and so on. But in order to explain here, we have a cat in a box that is simultaneously dead and alive. Okay? But if we have two boxes with two cats, we have different configuration. We can have simultaneously that the two cats are dead and alive, alive and dead, alive, alive. So with two boxes, the number of possible configuration is 4. With 3 boxes is 8. With 4 boxes is 16. So for each box added, I double the number of possible configuration of the different cats in the different boxes. Okay? And moreover, these cats can be connected among them. I can create a kind of connection between the cat in a box with a cat into another box. And if I perform some operation on a box, increasing the probability that the cat is dead, simultaneously I change the probability of the other cat in the other box. So a single operation can affect 2 cats simultaneously. So I am now introducing the concept of parallel computation, okay? Because by means of superposition, I have the different cats dead and alive simultaneously. By means of the entanglement, they can interact among them without communication. Okay? And so, if we have n cats, we have 2 to n possible configuration. And so we have an exponential quantity of information to store by means of only n boxes. Okay? And this is one of the main benefits of quantum computation, because the quantity of information that I am able to store in a quantum device is exponential with respect to the size of the device. Okay? So in a classical computer, if the classical computer is composed of a single register storing n bits, I can store only n bits. In a quantum computer composed of a single quantum register composed of n qubits, as we will see later, I am able to store 2 to n qubits. So I am increasing the quantity of information that I can store and also the quantity of information that I can manipulate. Okay? Okay. And so this is just a kind of recap of the topic that I have discussed, where we are replacing the concept of cats with the concept of qubits. So we are removing the cat from the box and we are introducing a bit in the box. The bit in a classical world can be 0 or 1. When I put the bit in the box, it can be 0 and 1 simultaneously. Okay? And I can relate different bits among them. When I act on a bit, the other bit is affected by this modification. Okay? And this bit live in this superposition of states till I open the box. When I open the box, these qubits collapse in a classical register, okay? In a classical configuration. So, in general, what is the impact of computation of this new configuration? Is that thanks to superposition, a quantum computer with n qubits can explore 2 to n possibilities at once, okay? Instead of trying them one by one like classical computer. And thanks to the entanglement, qubits can work together in a coordinated way, implementing some computational operations that are not possible for classical computation. And this is the way why quantum computer can potentially solve certain problem much faster. Okay, I like to say potentially because we have so far no theoretical proof that quantum computers are better. We have some example where quantum computers work better than classical computer, but there is no theoretical proof. Okay, only just example, but maybe in the future, a computer science genius can implement a classical algorithm better than a quantum algorithm, and we have to close everything about quantum computation. But when in computer science, when the time passes, yeah, we are confident that this hypothesis could be true. And the idea of quantum computers, the goal of quantum computers is to achieve the quantum advantage. A quantum advantage means doing something with a quantum computer that a classical computer cannot do in a reasonable time, okay? So just to complete this slide, there is a very simple operation that a classical computer is not able to perform in a reasonable time. That is the factorization. You know what is the factorization of a number? If I have 6, the number 6, the factor of 6 are 3 and 2. So I would like to have, in a very simple way, you have to have the list of numbers that multiplied among them return the original number. Okay, we learn at elementary school, maybe at secondary school, to how to perform this operation. And it is strange, but this operation is very hard for a computer. It means that you have a big number, and you would like to know what are the numbers that multiplied among them return this big number. A classical computer can use 1,000 years to compute. And indeed, when you use WhatsApp, for instance, your messages are encrypted thanks to an algorithm based on this problem. So the encryption of our messages are hard to be decrypted because this problem is hard for a classical computer. And this is one of the main reasons why quantum computers are very interesting today. Because with quantum computers, maybe we will be able to break this encryption algorithm on which our app are based today. Okay, indeed, there exists an algorithm named Shor's algorithm, introduced in 1994, that allow to perform the factorization in a polynomial time. Polynomial time means good, okay? And this is the strong interest in quantum computation. It's related to its capability to solve this problem, and this problem sometimes, like this time, are related to cryptography. Okay? And indeed, in the United States, there is the National Institute for Standard that is introducing the post-quantum cryptography algorithm. Yeah, because this algorithm exists, but there are no computer able to run them. But when, in maybe 15 years, 20 years, we will have computers able to run this algorithm, we have to completely replace our approaches to perform the encryption of data. Now, what is the goal? Why I would like to merge together AI and quantum computing? Because we can use a kind of metaphor. I would like to replace the cat in the box with a net. I would like to put in the quantum box a neural network. Okay? If I am able to put a neural network in the box, so I can use the superposition in order to have different configuration of the neural network simultaneously embodied in the box, and I can try to speed up the training working on this parallel version of superposition version of the neural network. So this is the idea, that I can try to speed up the training of a neural network by using the quantum principles such as superposition and entanglement. And in this way, also the next generation of AI tools composed of trillion of weights could be trained efficiently. So this is our goal. For instance, just to make an example, if we consider the current version of ChatGPT, ChatGPT is composed, as said before, by a number of weights between 500 billion and 1 trillion. And in order to store this number in a classical computer, we need tens of trillions of bits, okay? But by using a quantum computer, each n-qubit register can represent, as I said before, an exponential number of value. And for this reason, a quantum computer equipped with only 40 qubits will be able to store tens of trillions of bits. Okay, I need only 40 qubits to store all this information. Okay, today we have, at University of Naples, we have a computer composed of 40 qubits. IBM provide, by using its cloud system, computer composed of 127 qubits. But however, even though we have this computer, as we will see later, does not work properly. Okay? They have a good number of qubits, but they are not good. I explain now why. Okay, so this is a quantum computer. In particular, this is a quantum computer based on superconducting technologies. And we have an example of this computer at the Department of Physics of University of Naples. There are different technologies. Now, another problem with the quantum computation, now, if you see TV news, every week there is a news saying Napoli is the first city with a quantum computer. Torino is the first city with a quantum computer. Salerno will be the first city with a quantum computer. Every city will be the first with a quantum computer. In particular, these computers are based on superconducting qubits. That is currently the most suitable approach to build this kind of computer, but because the technology is not mature, there are also other ways to try to design computers, such as, for instance, trapped ions or photonic quantum computing that are based on the concept of light, spin qubits, and topological qubits. So there are different technologies we can try to use to implement a working quantum computer, but so far no technologies is useful to build a working quantum computers. What means that these computers are not able to work in a proper way? It means that we are living the so-called NISQ era. Okay, we are in the NISQ time. NISQ means noisy intermediate scale quantum. Okay, it seems hard to understand, but it's very simple. It means that the computers are small and noisy. What means noisy? Noisy means that when you perform a computation, the result is wrong. Okay, if you ask, in a very simple way, you don't ask to a quantum computer the sum between 3 and 2. If you ask the sum between 3 and 2 to a quantum computer, sometimes it returns 4, sometimes 6, sometimes 3, sometimes 5, and so on. So there is this noise in computation that not allow us to perform the computation in a right way. Moreover, the size of computer is small. Okay? The number of qubits that currently equip quantum computers does not allow us to face important problem. But we are working on, we can say, toy problem, introduction problem, and so on. In order, for instance, before I discussed about the Shor algorithm, the algorithm to factorize number. Okay? In order to implement that algorithm in a correct way, we need 1 million logic qubits, 1 million. Now we have 40, 50, 100. So we have to arrive to 1 million logic qubits, not noisy. Only when we will be able to build this kind of computer, we will be able to break the encryption algorithm of WhatsApp and so on. So we are far. Indeed, 2-3 weeks ago, the CEO of NVIDIA, this is a top company in computation, said that in his vision, we will have a practical quantum computers in 15, 30 years. Okay? We will be able to build a computer able to solve a practical problem in 15, 30 years. Maybe this is a pessimistic vision, but maybe 10 years is a good time. Okay, and then, as I said, currently with this computer, with the NISQ computer, we are able to run small to medium scale quantum algorithms. So we are able to solve little problems. Okay? Currently, classical computers are better than quantum computers in solving hard problems. And we can explore how, for instance, quantum computing can be used to improve artificial intelligence. That is our goal in our laboratory, in our department. And another important topic, I think my vision is that quantum computer cannot work alone. Okay? I see a quantum computer as a kind of sidecar. Okay? You have to put a quantum computer together with a big, a powerful classical computer to solve a particular problem. So in my vision, we'll not use quantum computers like we use our phone today or our laptop today, but that machine will be machine to solve very hard problem, in particular application domain, and so on. So you have to imagine these computers in high performance computing environment working together with classical computers. And now, there is another challenge. Okay? I say that quantum computing could be a benefit for AI. Because with quantum computers, we can try to store big artificial intelligence model in an efficient way. Okay? But however, there is also the other direction. The question is, classical artificial intelligence can be used to improve the performance of quantum computers. Because current quantum computers are not so good. Okay? But maybe using AI, we will be able to solve some issues related to this computer. And in particular, for instance, we could try to reduce the noise in computation thanks to AI. Or we can try to perform the so-called compilation of quantum programs in a more efficient way thanks to AI. So there is, when we discuss about quantum AI, we have to consider a bidirectional interaction. Because quantum computing can support AI, but currently AI can support quantum computing in working better. Okay? Okay, Now, after this vision about the integration of quantum computing and AI, I would like to show you what we done in our laboratory in both directions. We worked on the direction quantum for AI and on the direction AI for quantum. And in particular, okay, this is just the name of our laboratory. It's named Quasar, Quantum Computing and Smart System, funded by me in 2017 at University of Napoli Federico II. And this is maybe one of the first, maybe the first laboratory in Italy investigating about the integration of quantum. Yes, no, it's the first, like, yeah, maybe tomorrow there will be another first laboratory in Salerno, maybe. I think this is the first, just for a casualty, because when I come back in Italy from UK, I moved to the physics department, and I was lucky to, as a computer scientist, to move to the Department of Physics and to explore this new topic before than other. Okay, it's one of the first. And we would like to design intelligent system that combine the power of quantum mechanics with the reasoning capabilities of AI. So this is the direction quantum for AI. And at the same time, we would like also to work on AI for quantum. For instance, in 2021, we introduced the first genetic algorithm able to be run on a quantum computer. A genetic algorithm is an optimization algorithm inspired by nature. So we solve optimization problem at the same way how population evolves, following the Darwinian principles. Okay? But these algorithms were implemented on classical computers before. In 2021, we introduced the first quantum version, and it worked in a good way. We were awarded by IBM for this project, and thanks to this award, we were able to use the bigger computer of IBM to test the algorithm. Then we have introduced the first quantum fuzzy system. What is a fuzzy system? I will try to explain in a very simple way. Is a way to program computers, classical in particular, by using linguistic rules. Okay, I can like that. I have a rule: if the temperature is high and the humidity is moderate, then set the fan speed to medium high. Okay? Thanks to fuzzy logic and fuzzy system, I can program a computer by using the English words. Okay? And we say it's possible to make the same on a quantum computer. And there is a benefit. Yes, we proved that it's possible, and there is a benefit. What is the benefit? The benefit is, if you consider this rule, if we increase the number of variables in this rule, for instance, temperature, humidity, I add more variable, the number of rules that I can compose grows exponentially. And a classical computer needs an exponential time to run this rule. But on a quantum computer, we need just one execution, and in a polynomial time, we are able to perform this operation. And so we proved that is it possible to program a quantum computer by using linguistic rule, and you have a computational benefit. Thanks to this system is not only a theoretical system. We moved to the CERN in Geneva, and we controlled up particle accelerators by using linguistic rule and a quantum computer. Okay? And this is the picture from the control center of the particle accelerator, where our PhD student, past PhD student, now is a young researcher, is controlling a particle accelerator thanks to our algorithm. And the same algorithm has been applied to the control of a smart city. So we can control the different part of a smart city in a linguistic way by a quantum computer. We participated to the Fujitsu Quantum Award, and we won this award thanks to this project. So Fujitsu awarded us with $10,000 for our research. We were awarded in the Netherlands at the Fujitsu European Fujitsu Center. Yeah, because it's one of the practical application of quantum computation. Obviously, as said before, this is just a theoretical result because current quantum computers are not able to run properly our algorithm. But in an ideal case, if we suppose that the computer is ready, it works good. Okay? And Fujitsu Award does. Then we are also developing software to allow people to train AI models on quantum computers. And the software is named EvoVac. EvoVac is evolutionary algorithms for variational quantum circuits, okay, where we use genetic algorithm, classical genetic algorithm, to model quantum artificial intelligence system. And it works in a good way. It is strongly used. And starting from that research, we implemented an optimization algorithm for quantum computers, awarded as the best journal paper just 1 week, 2 weeks ago in Rome. Then, now, the previous slides are related to quantum computing for AI, but we also worked on AI for quantum computing. We use a clustering algorithm to collect the different kind of noise that a quantum computer is that a quantum computer suffer, okay? And by means of this algorithm based on unsupervised machine learning, we were able to improve the performance of IBM computers, okay? Better than the IBM algorithm to make the same activity, okay? And this research was another best paper award at a FADZ Tripoli 2021 in Luxembourg. And we are also working on the, as I said before, on the compilation. Yeah, when you run a quantum algorithm, you have to compile this algorithm in a form that is compliant with the processor where you would like to run the algorithm. And we used artificial intelligence to find the right transformation to run the algorithm in a good way. Then, yeah, beside the research activity, we are also working on editorial and conference activity. In particular, in 2019, we introduced the first journal in quantum artificial intelligence, and currently is a kind of the main forum for scientists working with this topic. And in November, we are organizing a conference here in Naples. It's the first conference sponsored by IEEE, that is the top entity, the top body for engineering in the world, on quantum artificial intelligence from November 2 to 5. Okay? And we are able to organize this conference because in 2022, we were awarded by the IEEE Computer Society with the Emerging Technology Award. So they provided us with some fund to create a research network in quantum artificial intelligence. And starting from this research network, now we are able to organize the first conference on quantum AI in the world. The next edition will be in Nottingham and in Athens, but the first is in Napoli this year. Okay, so in conclusion, why quantum computers are useful now? Because classical computer could be not able to further improve to support the next generation of AI tools, okay? Because, as I said before, we will be not able to make transistors smaller and smaller, okay? And for this reason, it is important to think an alternative computational paradigm such as quantum computing, because thanks to its features such as superposition and entanglement, it could provide a computational advantage in AI. Okay? But as said before, I think that we need around 10 years in order to have a kind of practical quantum AI system. But we are working to try to speed up. okay, the process. Okay, so thank you very much.